got, maybe the result. Can you hear me?
Yes, I can hear you.
Uh-huh. The result is like they are all in the same direction. Let's see if the result is significant from the main models, the result I'm getting the same significance. But the main model maybe is positive, but robustness I'm getting negative, but it's the same significance, and vice versa. Maybe I'm getting the same positive, but insignificant. What will I do if such a thing happens?
For insignificance, if the directions are okay, it's a bit understandable. You can use it in to some extent, but the when where it is having a different direction, then it's not good. It's not good because you can't say that using this model, I have a positive relationship, but using this model, I'm having a negative relationship. It means it is not stable. It is not stable. And the significance to some extent, if you are able to justify why you think that model is showing insignificance, then you are good, you can use it. But if you can't justify it, then you have to go and use a method that will give you significance. But if you can justify why you think it may be the way that model works, you can use the intuition or the assumptions behind that model and justify why it is given insignificant. But they are in the same direction, meaning it have a positive. It means it is positive relationship, just that it is insignificant. But different directions, it's not advisable to go that way because you are saying that using this model, CO2 influence negatively. Using this model, CO2 influence positively. So which one should we give decision? Should we base on to make decisions? No. So that one, they don't try it. That one, don't use it. But for the significance, you can find a way to justify it and rely more on the relationship being stable instead of the significance level. But if you have other models or other ways, that's why we have a lot of ways to do robustness. Maybe some of your models, if you have different variables, some will be significant, some will be insignificant. That one is fine, but maybe you have three independent variable. They are all showing insignificance in your robustness. Then it means you have to rework on it. Maybe if two or even one is showing significance and the others 10 insignificance is fine to some extent. Is that okay, Professor
Okay.
Alute?
Yeah, it's okay.
Okay. Any other question? Okay, so if there's no question, then I think we can proceed. So, and please, some of this model too, it uses the iteration process. And this iteration process, you need a laptop or a computer with a bit higher specs or specifications like the processors. If not, you can run a model and it will take like a day before getting your results. I think even this afternoon, I tried to run one model and it took like 30 minutes getting to 1 hour. So I terminated the model so you need at least a machine with appropriate or a good specification. So now we have our results. Let's run this is the Pullman group. We have the XTPMG. We have our dependent variable. The D here means first difference or lag 1. So this is how the uh, Pullman group works. So you can see that I intentionally did at 0 lag and then at lag 1 or 1 lag so that I want to know how different our result will be. So you can see that I added lag 1 of the GDP to the second model. So there is L dot D in GDP. So first difference, lag 1 in the first one. So let's run the zero lag 0, lag 0 for Pumin group. We are estimating both long run and then short run. Long run and then the short run. So if you want to use it, you can just change my variables to yours. Just change if your variables are not GDP. Here we have our dependent variable, CO2, PM2.5, nitrous oxide. These are our independent variable. Then we have our moderating variable, which is health. Then we have exchange rate, money, and then inflation as our control variables. Then we are estimating both long run and short run. So this is how the code is written. You have to repeat it. You have to repeat it, which is the GDP, the CO2, PM2.5, nitrous oxide, health, and everything. We're estimating EC. So you can just adapt this code and replace the variable with yours and then run it. So let's run it and see. Please, you can ask your question whilst it is running. As I said, this model takes some time before it runs. It works on iteration.
Okay.
So if you have a question, you
I
can
said
ask.
another follow-up question.
You can.
Okay, so about the robustness. Okay, so we were during our previous lessons, you mentioned that we can use time. We can use time also to check for the robustness, right? So, uh, so let's say with the main model, let's say I use lag of let's say 1 or 2. Okay, let's say 1. With the main models, with the robustness, can I also use 1 or I should use let's say 2 or 0 lag or something? I don't. That one is sometimes confuses me. So if you can
Yes,
explain that
you
one.
can use the same model you have used for your main work and run the same thing as your robustness. No, you can run the same model with lag 1. Your main estimate have lag 1 and the robustness to have lag 1. Then you are just repeating the main model as your robustness. So you can try different lags. So maybe you can use 0 lags, 2 lag 2, lag 3 or something to support it, to see the stability of the result. But you can't use the same thing you have used in your main estimate as your robustness.
Okay, okay, that's fine. And also, must you always address endogeneity?
Must you
Though sometimes you might have significance, but there might be issue of endogeneity.
endogenize endogenize, if you want to go to endogeneity now, then it will be a bigger problem for all of us. Endogeneity is one thing, one bigger problem right now in the economics arena. Endogeneity is one big problem in the economics arena. Is right now it's more theoretical, and the economics are trying to solve it or bringing a solid way of solving endogeneity. So it is accepted that you use theories to justify that there's no endogeneity problem in your study. But there are some models that we assume that it addresses endogeneity. And one is the GMM models, like the system GMM or the machine learning models, and even to some extent, the Pullman group and the others, and the two-stage least square. Those models are assumed that one way or the other, it addresses endogeneity. But you can go and read about it. Yes, it's a bigger problem right now in econometrics, and we have to discuss it more theoretically. Prove to the readers or the reviewer that there's no endogeneity problem. Endogeneity can be caused by a lot of things. It can cause by reverse causality. It can be caused by autocorrelation. There are a lot of things that causes even missing variables. A lot of things causes endogeneity and cannot be addressed by one model. But I think right now GMM is accepted as to address indigeneity. And I think instrumental variables. But if I'm not using any of these, then you have to explain why you think there's no endogeneity problem. So don't think
Okay.
about endogeneity in your model. If you want to solve endogeneity, then go and use GMM. Mhm. Yes. So mostly me, for
Right.
instance, I always explain it in my work and justify why I think there's no endogeneity problem.
Okay.
Mhm.
Right.
For endogeneity right now, there's no way to solve endogeneity 100% unless there's a model on the way coming, fully developed for endogeneity. But I think right now, GMM and least square instrumental variables are accepted. So this is our pool mean group regression at zero mean, sorry, zero lag. So we can see that we have the short run and then the long run. The long run is what has been labeled here as YC, which is the error correction. But you have the short term, the main error correction here, which is the 0.088. But I realized that our main variables are insignificant. Our main variables are insignificant. We have huge values here. And our long run to only nitrous oxide is significant. So we can choose to go with this result, or we can try other options too and see. Because if they are insignificant, then it's not giving that kind of vibe that we can use. So let's try like 1, 2 and see if we can get some level of significance. So you realize the time it took for this result to finish. I think we had 15 iterations. This one is even small. So let's try lag 1. Lag 1, you see that the difference between the zero lag and then the lag 1 is the L dot here. The L dot, you see that here we have only one GDP, D dot GDP, but here we have D dot GDP, and then we have the lag 1, which is the L dot D dot GDP. So this is the lag. This is the lag. This is the lag. And always, the more you are increasing your lag, it means you have more time periods. If your time periods are not enough, if you increase your lag, it will not work. So let's try lag 1, 2, and see if it will work. So it will take some time before it finishes. So if you have a question, you can ask. If you have a question, you can ask whilst we wait for the model to finish.
Hello, Seth.
Yes, please.
Yes, so in the code, I can see some replace there. That replace, what role is it playing?
Oh, it's not anything serious. You can just take it off. It's part of the command that I'm using.
Okay,
So you can take it off, it will
okay.
run. And that's one technicalities in this data and those codes. Yes. Something small can mess up your codes and everything. So sometimes it's better you get a code that has been used before and it work perfectly. If not, you can write like 100 commands and it will not work. So if you get a code that works, you just adapt it to your own. Look at the structure of the code and then adapt the code to suit yours and it will work. If you try to start from scratch, Obeka Kwem. So let's see.
Hmm.
Any other question? Whilst we wait for our
So, Seth, can we use machine learning to do all these things?
yes, you can use machine learning to run your result. Like you are using machine learning to run the Pullman group, or you are using it to estimate. machine learning model.
No, to run the pool win group.
Oh, but machine learning have its own models, which are different from
Mm,
econometric models. So machine learning models are also there. So
okay.
we have the random forest. We have the gradient boosting model algorithm. We have the natural gradient boosting. We have a lot of machine learning models, so you can use them. Pullman group is not a machine learning model, it's an econometric model.
Mm,
So if you are going with machine learning, then that one to have its own models there that you can use. It's also acceptable, provided you can justify why that machine learning is more suitable.
mm,
Yeah, so it's accepted. It's accepted. We have the causal inferences models, the double machine learning. There are a lot of models that you can use. So please, even this one, my machine is even having 16 gig. So look at the speed it is running. So if you
Uh-huh.
are attempting these kind of models, your machine can crash. Your machine can crash. Tavia, you hear?
So it's uh, uh,
I'll
I'm
ask a
seeing
question.
I think I'm seeing the attached variables. So that
I can't hear you.
when you check your models, check the models and you see we have D dot uh, dot is that difference?
I can't hear you.
I'm saying with your models, the variables you used, I can see D dot attached to the variables, and I'm asking the D is it difference or
Yeah, it's the first difference.
okay, fine. So I was also trying to run the same model, but me, I used AI to get the code, and AI was asking me to use
At level.
like to center my variables. Is it center mean or something like that? Yeah. So AI created the center mean variables. Then I used that one to do, but I was getting significant.
You are getting significant.
Insignificant.
That's why I said, beginning, I said that we have a lot of ways for presenting your codes. And sometimes you can run the same code and you will be getting strange results. So what I do is you can use a code that someone has used and it works and it has been accepted for publication. Always, because anything that you do, if the editor or the reviewer asks you to provide proof of your codes or your data and everything, you have to justify why you use that. So if you're using center mean or what you are talking about, AI can write a lot of things for you because AI has been trained, so it can combine a lot of things. If that thing has empirically been tested and accepted or not, it will write it for you. So it's better you look for a code. So most of the studies published in this top journal, they attach the code and the data as for replication. You can get these codes from there so that you adapt that code to suit yours and use that study to justify the use of that kind of command. So this one uses the difference. So first difference to write. Maybe if you have another one that use center mean, that one is up to you to justify why you think the center mean is accepted. And I'm saying that what we are learning here is to give us the overview or the structure of how everything works, the models from descriptive to robustness. But this is not enough, or this is not, what's the proper way? This is not enough, or this is not all. We have a lot of ways for doing it. You just have to know when to run something, the kind of models to use, the at what time do you have to use a particular model, what influences the adoption of a model. That's all that we are trying to do. You are not limited to what we are doing now. But the advice I can give is that do not rely on AI to write a code you have not seen before for you. Maybe if you have a sample code, you can give it to AI to adapt that code for you. So you can go to YouTube and watch. Maybe if I want to run a CSARD, I've not run it before. Before you give it to AI to write it for you, go to YouTube and watch a video of how CS is run, or look for a study that use CSARD. And if their data was attached, or that's why I say mostly use these top journals, they take the codes and then they take the codes and the data for replication. Then you can go and check the command they used. Then you adapt it. You can give that code to AI to adapt it or to modify it to suit your work before you use it. Before you use it. If not, you run something and later it will get you into trouble. A reviewer who is very intelligent when it comes to these things, these models, he will give you problems. I think recently one of my studies on, I was doing marginal analysis, and the paper I think is a third review now. I'll edit it. I'll go. The reviewer will say that no, use this code. No, this code is not accepted, and they will bring it back. I've done it 3 times, and still he has not approved it. So sometimes some of these reviewers, they know what they are doing. So try to use a code which has been used before. Please, are you okay? Alote, are you okay?
Hello, Seth.
Yes, please.
So you see how this one is delaying like that. If we go and run this module in Python, will it be faster than Stata or it will be the same time?
That one, there, like I said, it is based on your machine's processor and then packages and tools that you are using. Yeah. So there are some packages it can take a shorter time in Python or R, and it will take longer time in Stata, and vice versa. But me, I don't really advise using Python for such analysis. Maybe R is better. R is better when it comes to econometric analysis. I'm not saying that Python is not good for econometric analysis, but it is not built for that. It is not built for that. So you can use R.
Mm.
Yes. But R2 can crash your machine. That one too. It's not like you can just use programming tools and it will come. Yes. That one you can run a model there and it will take years before it comes. And it's normal. It's normal. It's not. I think Professor Dr. Kanta said, say you know Dr. Kanta. He said when they are running statistics for the Ghana Statistical Service, sometimes one of their model it takes like 12 hours. So he will run it and come to
Mm.
campus. By the time he goes back, then it is done. So it's normal. Just that
Mm.
if you don't have a strong machine, then you can go for a normal model like this called Cray, fixed effect, random effect, and those stuff. But if you think your machine is strong enough to handle these models, then you can go with it. So you can try it. I think you can try it when we are done. You can try to run Pullman group in R and C and run it also in Stata and see how long it will take before it finishes. If R is faster, then you can use R for it. But somehow there might be differences in the result. There might be some kind of differences in the
Mm.
result. Yeah, so you can do both, and the one that gives you better result, you go with it. Do not limit yourself to only STATA. We
Okay.
will have lectures, then we will introduce ourselves to R and then Python 2 and C. But today we are dealing with STATA. I don't want us to be using multiple softwares at the same time. Yes. Any question? So it is done.
Okay.
Oh, you can ask
I
your
was
question.
saying that can I do some of the tests like the pre-estimate in Stata, then I go and do the main model, go and run it in R?
Yes, you can do that. Why not? You can do that. You can
Okay.
do your pre-estimate and everything in STATA. So if you are disclosing it in your study, then you have to disclose. So I think the lag one give us a good result. A good result. So I think we will go for the lag one. So you can see that the error correction, which is the long run estimate. The long run estimate, we have significance for all our independent variable. But when you come to the short run estimate, the short run estimate, only the lag, only the lag is giving us significance. So it means that our health CO2, PM 2.5, and then the nitrous oxide have a long run relationship with GDP instead of short run relationship. It means the impact of carbon emission, air quality, nitrous oxide have a long run impact. It impacts our economic growth in the long run. So if you are making a decision, your decision should target in the long run, should target the long run impact, not the short-term impact. That's what the result means, because we can see that the CO2, PM 2.5, nitrous oxide have insignificant relationship in the short run. But health have significant relationship in the short run. Exchange rates have a significant relationship in the short, which makes sense. The result really makes sense because exchange rates, anytime the exchange rate changes, it will affect our economic growth in the short run because we can see the impact or the effect immediately. It have that kind of change. The same thing applies to money supply. If the government of Ghana or the Bank of Ghana introduce a lot of money into the system, it have an immediate impact in the economy. Inflation is showing insignificance, so that's fine. But the environmental impact does not influence economic growth in the short term, but rather it will have an impact on economic growth in the long run. So that's why the short run is showing insignificance. And yesterday we learned how to interpret the coefficient. We learned how to interpret the coefficient. So this is our estimate. So this one does not have the interaction. This does not have the interaction. Please, I want to run the one with the interaction. We know the time it will take, so I'll run it, then we will try to interpret this result. I've given an overview of what it means. Then we will interpret this result. By the time we finish, then maybe the the interaction will run. So you can see that from our structure, we are running two models, the direct impact and then the moderating effect. So we are done with the direct impact. We are coming to include the moderation effect or the interaction effect, then run it. So the main estimate, we are using pooled mean group, pool mean group, pool mean group. This study, when we are done, someone should go and write it for us to publish it. Pool mean group. Tevia, will you come for it? I'll give you 2
Oh
days.
yeah, I'll come for it.
2 days, so can you finish?
Mini
Okay.
alutebe.
Okay, so let's run the with lag and see. So we have the one with the interaction, with the interaction. Okay, so let me run it. This one, I know it will take a lot of time. So someone should help us. And my boss, Corban, Prince Nyakun. Hey, who is R? Samuel Darlington, my boss, Techi Dankwa. I can see Wisdom, Samuel Alote, Douglas. Someone should inform Douglas to join the meeting. I can't see Douglas here. Please help me to interpret the EC result. The CO2 PM2.5, you can interpret the long run and then the short run. So if you take the CO2,
So not from AI. I bet you above now on our camera.
hey, Alote, you see, I've catch you. Alote, you are telling someone to give the result to AI and read the AI to me, Alote. So please, if you pick the CO2, interpret both the long run and then the short run for me. Yesterday, we learned how to interpret it.
I said a question.
You can talk.
Yeah. The 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 moderation, the models with the moderation effects, right? If you are running it, can you take off the moderation variable? Like this one we are doing moderation variables, I think is CO2, right? I think CO2. Oh no, health health is a moderation variable, right? So let's say the interactions, if you are going to multiply the moderation variable by the independent. So can you take the moderation variable out when you're writing for the model?
If that one will give you the best result, then you take it out. That's why you see this one, I first ran you can see that I ran like 0 and I wasn't okay with the result. So I changed it to like 1. So in the same case as yours, if you think including the health is giving you problems, because sometimes these advanced models account for collinearity. So including the moderating variable sometimes can give you collinearity issues and can make your variables or your result insignificant. If you're experiencing that, then you can take the moderating variable out. The moderating variable is different from the interaction term or the interaction variable. In our case, the moderating variable is health, but our interaction variables are health times CO2, health times PM2.5, health times nitrous oxide. So you can take it out. If that will give you the best result that you want, take it out.
All right.
Yes. Any other question? Please, we should interpret this result. I'm more interested in the interpretation because that's what you are going to do. If AI interprets it for you and you yourself, you don't understand it, it's not prudent. You have to understand what your result means so that you'll be confident in the interpretation. So please, kindly assist in the interpretation of our results. Volunteers, please. You can pick CO2 or PM2.5 and interpret both the long run and the short run and give us what both means. Any volunteer?
So it's like the short run, no, I had distorted the alignment with the figures, name
Really,
variables, no.
really. Because of the second one I'm running,
Well, that
I can't stay here. It will go down.
um okay, I'll do only the long run.
Is this one okay? So which one are you? No, take one variable from both the short run and the long run and interpret.
Okay, so CO2
Okay. Can you see it?
for the long, it's small. Okay, it's better now. So for the CO2 long run, a 1 unit change in CO2 will cause a 26.389% change in GDP, and the result is significant.
That's the short run or the long run.
The long run, the EC.
So what about the short run?
The short run, the way the figures are arranged, I'm not seeing
This
which
is
one
the
belongs
short
to
run.
CO2. So the
The,
CO2 figure, is it the above or the below?
the below.
Ah, okay. So for the short run, a 1 unit change in CO2 will cause a decline of about 1.4% in the country's GDP.
Okay, great, great.
But the
So
result is not.
it's not significant. So please, that's how you interpret it. And we have the short run and then the long run. So you realize that the long run is showing significance. And that's why you have to use these models. Because if you use a static model, it will combine both the short run and the long run. And you will not know which run or which term or period is really working in the model. So if you use both long run and short run model, you get these differences. And the you see here is the error correction term. The error correction term. This error correction shows the period that it would take for changes or errors to be corrected. So the dependent variable is GDP. The error correction shows that in the long run, any changes, any changes in GDP in the short run, how long would it take for that error or for that change to be rectified or to be corrected? That's the meaning of the EC. And it's very important when it comes to this estimate. If there is a change in GDP in the short run, how long will it take for that error to be corrected? So the estimate or the coefficient is 3.33. So it's like 33%. So every year it will correct approximately 33% of the change. And it would take like 3 year period, 3 year period for that error to be fully corrected. So if there's any change in the GDP, if there's any change in the GDP, it will take 3 years, approximately 3 years, which is the here. the 33, the first three, or it's like 3.3 years. So approximately 3 period. Okay, let me use 3 period. It will take 3 period, but because we are dealing with annual data, it means 3 years. So if you are dealing with quarterly data, it means 3 quarters or 3 quarters. If you are dealing with semi-annual, and you get 3, it means 1.5 year. But since we are dealing with annual data, it means that every year we will correct 33%, and 33% we are correcting for 100%. It means every year 33%, 2 years will be 66%, and 1 year will be 99%, averagely 100%. That means it will take 3 years for it to be rectified. Please, do you understand it? Please, do we understand the error correction?
Yes, please.
Okay, please, boss. So 33% means that every year period. Yes, boss.
The error correction, is it for all the variables, the 33% for all the variables together?
Yes. So it's the variables that are causing the
Okay.
change in the dependent variable. So if there's any change in the GDP, it is caused by all the independent variable. So the changes in the GDP
Okay.
in the short run will be every year period, it will correct 33% every year or every period. The reason I'm saying every period is that sometimes your data structure can be annual, semi-annual, or quarterly, but in our case, we are dealing with years. So every year, there will be a correction of 33% of that error. So it will take like 3 years, approximately 3 years to correct every change. That means in the long run, So any changes from CO2, carbon emission, everything in the GDP will take 3 years for that error or for that changes to be corrected, or to bring the GDP back to its original position. Okay. So that's the meaning of the error correction there. That's the meaning of the error correction here. And it is significant, highly significant, and it is negative. If you get a positive EC, there's a problem with your model, which you need to look into the mirror. So normally, you should have a positive EC, because EC is showing correcting an error. So it's like if the GDP move or changes or shift from its original position or its trajectory, you are bringing it back to where it was. So it should be an opposite direction. It should be an opposite direction. That's why the EC is mostly negative. If there's any change in the original position of the GDP or the dependent variable, it would take the number of years in the EC to bring it back. So in our case, 33% or 34% every year period. It will take 3 periods to make 100%. That means it will take 3 years for it to be corrected. Thank you. Let's see if our model is done running. Yes, we are still going on. So please, any other person to interpret any part for us? We have to be fast so that we can estimate our robustness and finish with it. Please, someone should interpret the PM 2.5 for us. Please do it. It will help you. I know it will help you. You can try to interpret the PM 2.5. It will help you. Any volunteer? Any volunteer to interpret the PM 2.5 for us?
Original said.
Boss.
Yeah, I think like what my brother said, a unit change in the PM 225 will cause a 12.03% change in the GDP in the long run. But I think in the short run, um, it is going and it is significant in the long run. It is significant 0.00 years. I'm coming. But in the short run, I think a unit change will cost about one. Is it 16? Again, it will cost 16.4% change. Or I'm mistaken. I think
Yes.
it's is
100,
it
I
one
think
point
160%. Yeah,
yeah,
160%.
164. I think something like that.
But it's not
Yeah,
significant.
164%, and it is not significant. I think that is the little I can see.
Yes,
I
I
don't know
think
if
that's
I'm correct.
yeah. So that's it. So we
Mhm.
realize that in the short run, these relationships are not significant, and you have to
Mhm.
interpret why you think you are getting. And to me, it makes some kind of sense, or it makes sense because for environmental impact, you will not feel that impact immediately if
Instantly. Yeah.
there is kind of air pollution, carbon emissions, those things, fertilizer uses, and those things. It will not immediately affect the country's growth, but the real impact will be felt in the long run when maybe people are getting sick, it's affecting health, agricultural productivity is coming down, and a lot of things. That's where the country will start feeling it. Maybe water, because of pollution from these things, it will cause water pollution and those things, which in the long run will affect the country's growth. So mostly environmental impact is felt in the long run rather than the short run. But you can realize that the control variables, which is exchange rate, money supply, and those things, are having significance in the short run. That means if there's a change in exchange rate, it is felt in the short run. And even in the long run, it is still significant. That means these things affect or is being have an impact on GDP in both long run and short run. But environmental impacts are felt in the long run based on this model. So you have to justify it, why you think these things, you are getting this result, and then you support it with literature. You support it with literature. The same thing applies to the nitrous oxide. Realize that in the short run, it is insignificant, but in the long run, it is significant. And I've also explained the EC, the error correction. Let's see if our model is done, which I doubt. So, like Teria said, you can try it in R2 and C. So imagine if I'm using 8 GB memory, then this will take, I try to run this one, the heterogeneous analysis. I'll give you the code, but I will not run it. That's what I said. I tried to run it, and it was taking like 1 hour to run. So I will not run that one, but I will explain the command. Then maybe we will try the different lags and see. So different lags, and then alternative estimators. We will try the Discocre, and then I wanted this to finish so that I can extract the result and then we present it. Then we do like two robustness, then we are done with the study. Then we can start writing it for publication. So let's hope this one finishes soon. This one finishes soon. Any questions so far? Any question? So I think right now we will not do the heterogeneous analysis, but I will give you the code. We will not use the time effect. These things we will not write it. So we will use maybe different models. We will use only different models, and maybe the lag, maybe we can use lag 0 or lag 2. But I've run lag 0 and I've run lag 1, and I said we should go for lag 1 because that gave us a better result. So let me use different models. So maybe we will use DKSE as our robustness. We will use so the DKSE, we will use both FE and then DKSE, RE. The DKSE is the score create standard error fixed effect. The score create standard error random effect. Then maybe we can use PCSE. But you can also use the cross-sectional ARDL as your robustness. But this result, if you try to run these models today, we will not do anything because I have the ARDL command here. So when I share it, you can use it. That's the perfect model for the robustness, but I will not run it. It will take all our time. We also have the standard effects here. Then the random effects models also here. Alternative dependent variable. If you want to use a different dependent variable too, that one too is fine. Maybe you can use a different measure for GDP. You can use a different measure for GDP to run, but in our case, we will not use it. The time effect to you can include a time trend. You can include a time trend and then you use it. You can use or you can include a quadratic time trend. You can include a quadratic. These are all ways of doing how do we call it? A robustness. A robustness. You are checking whether your result is stable. So you can try this one too. I think based on the running of the model, I will not even try it because we spend all our time waiting for this one to run. So as I said, these ones run early. So I will use this model as our robustness. The Discord-Cray PCSE as our robustness. And then we will interpret our result and then leave here. So let's hope that this one finishes anytime soon. Please, is there any question? Because when we end this lecture, we will not come back to this one again. We will not come back to, because now we are done with the structuring the manuscript, and from the beginning of the analysis to the end, from the beginning to the end, we have done everything. Now we are left with only the main estimate and the robustness test. So when we get that one too, I think we are good to go. We are good to go. We can start doing some. When it comes to the writing, you have studies on writing, references, and those stuff. But the manuscript proper, or the structure, I think we have done what we need to cover. What we need to cover. If there's certain things you missed, you can always go back to watch the videos. This thing too should run it. And this thing, the thing is, you can even get not concave, and it get to a point and it will break. It will break and the result will not come. They will give you an error. So please, you can talk.
I'm saying if it breaks, does it mean you have to run it again, start afresh?
No, it means you have to change something. Either you change the lag or change something. Either it was some of your variables are behaving some way in the model, or mostly sometimes it's because of the lags. Yeah, sometimes because of the lags.
Mm.
And
Okay.
it's normal. The time it is taking is normal. So don't worry when it is taking a long time. It will come. Just have to go and sleep. By the time you wake up, now it is ready. Any question so far on all that we have done? If there's something that you want more explanation to.
Hello, Seth.
Yes, please.
So I've been thinking that those in sociology and history and all, when they are doing research, did they also do this analysis some?
If your study requires it, you will use it. But mostly some of them uses qualitative analysis or primary data. If you are using primary data, you can use the smart PLS. Most of them use the smart PLS. And we have models which are suited for them. So they goes with the logistic regression. If you check their studies, most of them use the logit, probit, the logistic regression, OLS,
Mm,
fixed effects, normal basic fixed effects, basic random effects, and mostly qualitative studies. They collect data through
mm,
interviews, then they use in vivo to analyze them. Yes, but they also follow same structure, just that some of the pre-tests they will not do, like the cross-sectional dependency, they will not need it. Because when you are dealing with primary data, those things are
mm,
not needed. If you are dealing with primary data, cross-sectional dependency, slope homogeneity, those things are not necessary. Because they mostly deal with primary data. They goes for the basic models, like the logistic regression. That's what they mostly use when they are doing quantitative analysis. And we will get there so that every part will benefit. This is mostly for the econometrics, but they also follow the same process, just that maybe the analysis side will change.
okay.
When we get time to, we will also do qualitative analysis and see. I think we have people from those fields also here. That's why we created the link so that everyone
Mm,
will share their areas so that we will know how to incorporate all angles. But it seems the feedback we got from that link is in line with what we are already doing. Yes.
mm.
Or you want to enter there too.
I want every area. I want to do a holistic thing.
Yeah. So we will do
Mm,
primary analysis. I think we already have videos on Smart PLS. And Smart PLS is for every field. Health,
mm,
accounting, finance, sociology, everywhere. Because we use questionnaire and those things at every level or any field. So you can always go and watch the Smart PLS videos and abreast yourself with it and explore it. And also the logistic regressions, basic OLS models, the fixed effect models, they are for those fields. Mhm. And we also get time and do qualitative
o-
analysis.
okay.
I'm
Then
hoping,
sometimes when we download it, we realize that there are some missing values. Those ones, how do we deal with them?
Yes, that one too. I think anytime soon we have to have session on data cleaning. We have a lot of ways for filling missing values, depending on the kind of missing values you are having. If there's missing values contains like 20%, you have 20% or 30% of the data being missing, then that variable or that entity should be dropped from your data. And if it
Mm.
is like 5%, 10%, or it's not enough, we have ways of filling it. We have the iteration method. Uh, we have interpolation, mean interpolation. We have a lot of ways for filling it. Sometimes too, you can use Excel. We have ways of filling it in Excel using the mean. You can calculate for the mean of that country or that year. So if it is one country, you can find the mean and use that mean to fill it, or the missing figures. Or sometimes too, you can look at the trend of the values. If it is just a single missing values in it, you can fill it with the mean. Sometimes you can put zeros there if it is not many. Maybe you're having like 3 or 4, 2 missing values. You can put 0 there, or you can put mean there, or you can
Mm.
find average of that year, then use it to fill. We have different ways of filling missing value depending on the how it is missing. But if it's more, if it goes beyond a certain number, then you have to drop it. You have to drop it. Because if you fail it, it will have a serious impact on your result. Yeah, so
Mm.
we will try to have a session anytime soon on data cleaning. But I think that's some ways that we use to fill. So right now, you can use the mean to fill it. You can use the mean. Yeah.
Okay.
Any question from any other? Think today the model that we chose is bigger than us. It's bigger than what we can accommodate. I wish we didn't have introduced the moderator. So when I included the moderator, I realized the time it is taking. We are almost at 90 something iteration. So if you have any question, you can ask while we wait. I'm hoping we will get it anytime soon so that we can. Or let me try my other STATA so that we can bypass it and run the I have two status. I have the STATA 17 and the STATA 18. So I've opened my STATA 17. I'm trying to run the robustness here.
Oh, okay. So you can use two STATA on the same PC.
Yes, you can.
Mm.
The result has come. So I think
Okay.
yeah, we have the result here. So I think our nitro. So please know your machine strength before you try this mode. If you don't want trouble, use fixed effect Discord create and get a justification for it. If you have a strong machine, then you can try it. Even my own, it took like 20 minutes before it finished. Okay, so now we have the ones with the moderation. So this is the moderation. So realize that our moderation is significant. Our moderation is significant. The PM 2.5 and the nitrous oxide are significant in the long run. Money, let me see. So in the short run, none of them is significant. None of them is significant in the short run. So our moderation is working, and our EC is still significant at 10%. Our EC is still significant at 22%. So 22% is like it would take 22 per year. So like 4.5 years. Please, is that true? 4.5 years. Yeah, so 22 times
4
5 or times 4. So let's say 4.5 or
4.5.
yeah, 4.5. So it will be around 4.5 years before it corrects. Yes. So every year to correct 23%. 23%. So when we add the moderator, so let's put our result in a table. Then we go and insert it. Please, if you have a question, you can ask. So I'm trying to save put the result in a table. Then we put it inside our work. Let me see how it will arrange the table, if I like it. Yeah, so that's it. So it has given us the long run, then the short run, yes. And then we have our error correction. We have our error correction. Perfect, 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 perfect. Perfect. Mm. So we have our model estimate here. So we have model 1 and model 2 here. And this is how mostly we present results. Just show the coefficients and then the significance and then the standard error. So the ones below in the square, in the brackets is the standard error. And then this one is the coefficient. The star signifies the significance level. So you don't have to show the full table result in your work. Yes, so this way is perfectly fine. Then you can take the lines off from it. This is how you format your tables, yes. So you have the PM 2.5 significance in the long run, nitrous oxide significance, and everything. So this is how you present your results nicely. Then you have the short run here. Short run, then we have the long run here perfectly. Our error correction is here. Is here, and it is significant. Then we have the model. And so this one, you can take the constant off, or you can also show the constants. They are all fine. It's your own work. Present it the way you want. Yes. So let me put a line here. Yes. So this is our result. So standard error is the one in the parentheses. Then this one signifies the significance level. So model 1 is the baseline specification without interaction. Model 2 includes interaction term between pollution variables and health expenditure. The error correction coefficient indicate the speed of adjustment to long-run equilibrium. That's what I explained. All variables are in natural log form except inflation. That one too is noted. And I said the post-estimation, in our case, the best one to use is the CSARDA, but I don't want to run this. We just have 4 minutes. We can't run that model. If not, we will not close today. So I will use a different model. The heterogeneity to, you see, the codes, I have break the countries into a segment. I generated a group. I grouped the countries into 3. One is larger economies, Sahel countries, and then coastal or small economies. So I'm having 15 countries. 15 countries. I grouped Nigeria, Ghana, Cote d'Ivoire, Senegal as the larger economies in West Africa based on their GDP. And then Benin, Burkina Faso, Mali, Niger, Togo, they are the Sahel countries, the Sahel countries. And then the coastal and then the small economies, I combine the coastal and the small economies to be Cabo Verde, Gambia, and then Guinea, Bissau, Liberia, and then Sierra Leone. So you have to group this. This is what we use for the heterogeneous analysis. Then when you are running the command, you use you use the country grouping to run it. So the command will run for 3 groups. It will run for the larger economies, the Sahel countries, and then the coastal countries. Then you can do comparative analysis. That's fine. But I tried this command. It took almost 30 to 1 hour. So I'll not run it, but it's there. That's how we do the heterogeneous analysis. So if you want to do the heterogeneous analysis, so if your data have companies, you can group the companies. If you are dealing with only 4 or 5 countries, then there's no need to create these groups. Just go straight and use the countries, and it will run for each countries or each country. But if you have a lot of countries, like this one, we have 15 countries, we can't run for each country, so we have to group them. That's what we did here. Then the lag 2, we ran for lag 0, and I said the result, I don't like it, or it didn't give us a reliable result because our variables were showing insignificant. So I will not go for lag 0. Lag 1 is what we used for our main study. The main estimate, we used lag 1. So we can't use lag 1 as our robustness because that's what we used for our main estimate. Lag 2 would take a lot of time. So I have the lag 2 here. I have lag 3 here. You can try any of them. You can try any of them. It will give you the results. Then you compare. If you like it, you can use it as your robustness. Fine. So I will try to use this basic model, 3 of these models for our robustness. I have here the score-crate effect, the score-crate fixed effect, the score-crate random effect, panel corrected standard error. These are some of the basic models, and they are fine. This is the CSARDA. That one too, I will not try it because our time is almost up. Even we have just 1 hour. We don't have another time to wait. So let me use these 3, the discrete fixed effect, discrete random effect, and then panel corrected standard error as our robustness. That one there, it will not take any time, it will come. So the discrete, you just have to use XTSCC, XTSCC, XTSCC. Then you select your dependent variable. Then you select your independent variable. And then your control variables, you add your moderation. You add your moderation. So let me run it. I will run the first one. Yes, so I've run it. Let me close this once more. Okay. Okay, so we have the discrete fixed effects. That one too, I think all our 3 indicators are significant. They are significant. CO2, PM2.5, nitrous oxide are significant. But so you see, the fixed effect only estimated. This is the static models. It just estimates it. No long run or short run, it combines everything. That's why if you test for co-integration and there's a presence of co-integration, use a model that tests for both short run and long run. You see that discrete only tests for a single or a static relationship. No long run, no short run. So it combines everything. It combines everything. That's one. That's why it is not advisable to use when you have co-integration. So I have random effects. Then let me run the panel corrected standard error. So let me use these three results as my robustness. Please, if you have any question, you can ask. Okay. So please, the tables, I'm not getting time to cross-check the results if the AI is using the correct figures. But you have to cross-check it. You have to cross-check at least 2 or 3 or 4 and see whether it is picking the right figures. But for my AI, I trust it to use correct figures. But still, you need a second check to see whether it is using the correct figures. Okay, so this is the manuscript structures. Okay. So now we have the post estimation or the robustness test. So I have my robustness checks. But this one is a static model. I've said it because it is estimating just a static relationship, no short run and long run. That's why if you test for co-integration, it's better to use a model that checks for both, like this ARDL, the pool mean group, the mean group, and the other ones. So now my robustness, I'm using the Discord-Cray fixed effect, Discord-Cray random effect, and then the PCSE. So this is what I was talking about. So our main model, CO2 is having a positive relationship. CO2 is having a positive relationship. So we can see that CO2 in Discord-Cray have a positive relationship. Random effects have a positive relationship. PCSE have a positive relationship, which is fine. Though there are slight changes in the coefficients, and it is fine. It is fine. So you can even see that the random effects and the PCSE is having a similar coefficient, which is okay. The PM 2.5 have negative relationship here. It have a negative relationship here. It have a negative relationship here. And when you check our main model, it have a negative relationship, which is fine. So you can even see that when we included the moderation, the relationship changes. The relationship changes. It means the health expenditure tries to reduce the impact from PM 2.5. So when you include the moderation, it means that when we introduce the moderating variable into it, the negative relationship changes from negative to positive. This is different from the robustness. Please, this is different from the robustness. Robustness means you are testing the stability of your model. So it should give you similar result. It's different from the inclusion of moderating variable. So moderating variable can change your results. That's fine. But testing for robustness should not change the direction of your results. Okay. So that's fine. So this is we have 330 observation, 15 countries, R square, we have 87, 98, 65, which is acceptable. We have maximum lag of 2 here. The Discord-Cray use lags. The rule, this one used the rule, which is 0.886. So the estimator fixed effect, pool OLS, Praise Winston. The PCSE used the Praise Winston estimator. Discord-Cray, panel corrected. Cross-sectional correlation, yes, yes, yes. Because there was a presence of cross-sectional dependency. Common lag 2, common lag 2, common AR 1. So you have to show that from your results. Now our result is ready for. Please ask your question.
Yes, right. Okay, so as we said, if you test for co-integration and there's co-integration, you have to use a model that will solve for co-integration issues. Okay. So maybe if I'm trying to use the CSADRL, and I'm struggling to get, or let's say I'm struggling to go about the model, can I just forget about the quantification and go for discovery? Since
Yes,
that one don't
you can use
change the
Discovery.
effect
That's
of.
why I said you can use Discovery and justify using studies that have used Discovery. I've done some before. The political economy paper that I shared, I used Discovery, although I had co-integration, I had cross-sectional dependency. You just justify, say, it's enough to be used because this studies, blah, 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 used it. And also based on the structure of your data and a lot of things, just find a way to defend it or justify why it is suitable and you are good to go. But first, you can test the long run and the short run and see if the result is okay. If the result is not okay, then you can go by other process. So now we are done. We are done. Left with interpretation of the results. Maybe if we have time, we can try the CSARDL and see. Please, any question before we bring the session to an end? So we are done with estimation. We have started from descriptive analysis to robustness. And you have to interpret your result. Then you move to your writing. If your result is ready and everything, you can move to the writing part of your work. Then you can start writing. You can start writing, interpret everything, do your methodology and everything. Then you can publish it. So this one, we will publish it. Maybe I will need volunteers to assist in the writing. If you're interested, you can DM me or Frank. You can DM Frank or me. Then we will give you part to go and write. Then we will add your name to it in the submission. Please, any question?
Hello, Seth.
Yes, please.
Last week you were saying that you would have one-on-one sessions with us during the week. I don't know if that's still the pipeline.
This issue.